Hi, in this lecture we will talk about the relations of collections and tables. You will learn how to store a collection in a table column and then how to select that from the table, and you will learn how to query a collection just like a table. In our previous lectures, we said that we can store V-arrays and nested tables inside our tables. But we cannot do that with the associative arrays because we cannot create associative arrays as schema level. The Oracle database stores V-arrays and nested tables with some different methods. They differ in both coding and storing style. So we will start with the V-arrays and then continue with the nested tables. Let's think about a scenario. We have a table. That table has the information of employees. This info has the phone numbers. Normally, how do we do that in a relational database? We create another table for the phone numbers and establish a connection between the employees table and the phone numbers table. Then join them while selecting. At that point, we can use V-arrays and nested tables in a column so that we will store and use easier. When is this usage beneficial? It has more performance when you need to join. I mean, if employees table is a big table, when you join that with phone numbers table, it will be costly. But this usage decreases that cost, especially when the V-array data is lower than 4 kilobytes. Because if it is below 4, it is stored in that column. Otherwise, it is stored in another table. That table is created by the system automatically and resides in the same table space and in the same segment with the actual table. We know that V-arrays have fixed number of elements. That means the size that you allocated in the memory or disk is fixed even if you add any value in it or not. So when you assign a V-array as a column of a table, it is pretended just like another data type, so it is stored in the same table. But to store in a table, our type must be created as schema level. We learn how to do that. Now, let's create a type in our schema then. But first, let's create a record type for the phone numbers. Create or replace type t_phone number as record, and the type is p type varchar2, let's say 10, and p_number is varchar2, let's say 50. Now let's run it. As we can see, we had an error. Why? Because records cannot be created as schema level. We can have records only in subprograms like an anonymous block, function, package, etc. We cannot store records in our database directly. You can say that we store the collection type in the database. This is also a type, yes, but Oracle does not let us to store records in the database. But instead, there is another object like records that we can use in our database. It is object. We can create an object type, store it, and use it inside of our V-arrays. I will create lessons about the objects in the future lectures, but for now, you can know that objects can be created as schema level and we can use them like records. And in this code, the only difference is changing record keyword with the object keyword. So let's do that. Let's run it again. Great. Now we need to create our V-array type including that object. Create or replace type v_phone numbers as V-array, and the size is 3 of t phone number. Let's say our employees will have 3 numbers: home, work, and mobile. Now let's run this. As we can see, we have created our V-array. We know how to create that in our previous lessons. Now let's create our table including that V-array type. Create table amps with phones, employee ID, let's say number, and first name, let's say varchar2, and 50, and last name, let's say varchar2 50 again, and phone number, v phone numbers type. Let's run it and see if it works correctly. As we can see, I used our V-array type as a column of our table. Very good. Now we have a column that have 3 columns in it. Columns inside a column. Pretty fine. Now let's select from our new table. Select all the columns from amps with phones. As we can see our new column, phone number, but with no data. Now let's insert some data in it. Inserting a table with V-array is a bit different. Now let's write it. Insert into amps with phones values. Let's say 10. 10 is for the employee ID, and first name is Alex, and let's say last name Brown, and our phone number is V phone numbers. Now we know that V phone numbers is our V-array. Now we can add 3 variables in it. Our variables will be of the type T phone number object, as we can see. Our V phone numbers V-array consists of T phone number objects type. So we will add the values by using the constructor method of T phone number object. So let's see how to do. T phone number, let's say home, and let's say 111.111.111. Not important. As we can see, our object type name and the variables in it. But be careful. First, we write our V-array name, and in parentheses, we write our types, and inside of our types, we write our number type and number values. This number is phone number. Do not mix that up. Good. I indented differently for you to understand better. Let's write the other numbers. We use the constructor name again. Let's simply copy that and paste in here. Let's say the second one is work, and the third one is mobile. Let's change this. And this one is free. Let's run it. Great. Now let's copy paste that code and insert a new row with different values and numbers. This time I will have 2 values in it. Let's copy that. And paste in here and run it. But before running, let's change our values. Let's say this 0. And 4 for this. Let's run that. Alright, we ignored one value so that we can see if we can add less values inside 3 rows v-array. We could insert with 2 rows too, as we can see. Let's comment our changes and check what is there in our table. As we can see, our phone number values are not in a readable format. Now, there are 2 ways to see these values. The first one is clicking on this Run Script button. Let's click on this. But before that, let's clear our script output and click on this. With this way, we can see the data with the types. This is our type and this is our data. But most of the times, this will not be so beautiful to see, because generally there will be so much data in here and it will be hard to scroll and see them all. So we can see that with a better second way. For this way, we join our table with the v-array in it with using the table operator. It seems complicated, but not so much. Let me show you how to do it first. Then I will explain that on the example. Select e.firstname, e.lastname, p.p_type, and p.p_number from amps with phones. And alias is e. Now I write my table operator, table, and inside my table I write e.phone numbers. Phone number is the name of our column. Now, what we did in here, we joined our v-array column with the actual table, but with using the table operator. The table operator enables us to use the collections just like a table. They are pretended as 2 different tables. So we could query these columns in one select statement. Now, let's run it and see how the result looks like. We have forgotten to write an alias for this, so I write p and run the script again. A pretty beautiful result. Every row of the main table are printed for each value of the v-array. But the thing is, even if the v-array have 3 rows allocated, we inserted 2 rows in the second insert. So it has shown in 2 rows, not 3. Great. Now we know how to store v-arrays into the database, inserting into the table and selecting from the table. Nested tables are pretty similar with the v-arrays. We know that v-arrays can be in the actual table or in an automatically created table. But in nested tables, the nested table data is stored in another table in all conditions, because nested tables can sparse, so it cannot be in the actual table. This system generated table is called as storage table. This table is in the same segment with the actual table, so the joins with the actual table will be very fast. The inserts on the storage table is done by the system, so you should not touch that table directly.